Calling conventions. Every function has an interface with the external world. It takes some input from the outside, and then it produces something. Sometimes it produces something, and then it outputs the product to the external world, or maybe the result to the external world. But how can we know which calling convention to use? For example, how can we know how to pass arguments to a function if there are so many ways? How can we know which interface to choose? The answer is simple. Every interface is good. Also, every way to get input and to produce output could be good in some ways. It is just about deciding. You have to decide which convention to use. If you do everything by yourself and write all the code by your own, it doesn't matter which way you choose. You can just choose whichever way you prefer. However, if you are going to deal with other people's functions, or maybe if you work with other people, you have to decide on some convention or some common interface to the function, which all of the functions are going to have. Assume, for example, that you write some function, and then a friend of yours wants to call this function. How can you know which way to call it? Maybe you used registers, or maybe the stack, or maybe some global data. He can't know. You have to tell him how to call your function. There are some other cases. Maybe your friend is a C programmer, and you are an assembly programmer. How can you call a function that was produced by a C compiler? Maybe even both of you are C programmers, but one of you uses one compiler and the other one uses another compiler. We have to find a common way. You don't have to worry. There are some common ways to call functions. Assuming that we chose the stack to pass arguments, because the stack is a pretty general solution to pass arguments, there are some more decisions to be made. For example, who is going to clean the stack, the caller or the callee, and also how to pass output from the function. And those questions are asked assuming that we chose the stack to pass arguments. There are some other ways, but if we chose the stack, we should deal with those questions. So let's try to find out the possibilities. Let's begin with cleaning the stack. The question about it is, who should clean the stack, the caller or the callee? We can see here two different examples. On the left, this is an example we have already seen, in which the caller has the responsibility of cleaning the stack. On the right, we see another example. As you can see, we don't have here the add ESP8 instruction. Instead, we have this. We have a ret instruction with an argument. This is something that you haven't seen before. I haven't told you yet that ret can take an argument. So let's talk about it now. This is a different form of the ret instruction. Let's describe what this instruction actually does. It first pops a dword x from the stack, which is just some dword, the last dword, the dword on the top of the stack. It then jumps to this location. And finally, it increases ESP by 8. The only new thing about this new form of ret is this last operation, increasing ESP by 8. Instead of increasing ESP here at the caller, we increase ESP at the callee. Technically, those two pieces of code do exactly the same thing. But regarding conventions, different things happen here. For example, if accidentally you want to call this function and you didn't know that it cleans the stack, you might accidentally clean the stack yourself, and then you will be in trouble because the stack will be unbalanced in the end. Or maybe you wanted to call this function and accidentally you think that this function is going to clean the stack itself, so you omit this instruction, which is also going to get you into trouble because the stack will be unbalanced again, just to the other direction. So we have to choose which way we want to go. Maybe the caller cleans the stack or the callee cleans the stack. Those two schools of cleaning the stack already define two calling conventions, two very famous calling conventions. The cdecl and std call. In the cdecl calling convention, the caller has the responsibility of cleaning the stack. However, in the std call calling convention, the callee has the responsibility of cleaning the stack. cdecl originates from the C language, and std call originates mostly from Microsoft, from the Microsoft API. Maybe, for example, you remember the exit process function that we see all the time in all the example code. This function follows the std call convention. Next time that you see this function, exit process, take a look at it and you will see that the caller doesn't clean the stack. Exit process cleans the stack by itself. Return value. The output of a function is also called the return value. And return value is something which is very important to high-level programmers, because they use functions in a syntax which is a bit different than the syntax we use. If you ever talk to a C programmer and he tells you about the return value, you should know that he means the output of the function. Both cdecl and std call conventions require that functions return value in EAX. As an example, I show you again the function myfunc. Here we can see that the result of this function is going to reside inside the EAX register. Returning value in EAX is a very common idiom in the x86 architecture. I think that I don't know about any calling convention that doesn't return value inside EAX. The order of arguments. In higher level languages, function arguments are sometimes said to have order. And by order I mean first argument, second argument, and so on. I put the order in quotes because the order is just an idea or a perception. There isn't really any order. If, for example, I pass the arguments with the registers, then absolutely there is no order. There is just one register and other register. But many high-level language programmers write functions like this, in one line. And then the arguments have some natural order that comes from the order on the line. For example, here, a function called SumFunc is called with arguments 2, 9, and 1. A high-level programmer would say that 2 is the first argument, 9 is the second, and 1 is the last argument. I want to give you a rule of thumb to be able to understand which argument is the first and which one is the last when thinking about the order of arguments. With the cdecl and std call conventions, the last pushed value is the first argument. Let's look at a concrete example. If we want to call this function SumFunc with those arguments, this is how we are going to do it, for example, with the cdecl convention. The order will be the same with the std call convention, of course. This is the first argument, 2. This is the second argument. And finally, this is the third argument. This is the first argument because it is the last one to be pushed into the stack. You might be wondering, why do I have to tell you about the order of arguments if this is just an idea or perception? Why would I tell you about it if only high-level programmers care about it? The answer is simple. You might have to talk to high-level programmers at some point in your career, and maybe you will even have to read documentation of higher-level programming languages. Most of the Windows API, for example, is written in this kind of format. So whenever you see this format of a function, you will know that this is what you have to do. You will know that this is the order of pushing of the argument. Summary of this lesson. We have seen three methods for passing arguments: through the registers, global memory, and the stack. We talked about calling conventions and that they mostly help connect different pieces of code, or maybe different pieces of code written by different people. We have learned about two major calling conventions regarding using the stack. Those are the cdecal and the stdcall. cdecal originates from the C language, as opposed to stdcall, which originates from Microsoft and the Microsoft API. Most of the Microsoft API uses this convention. The cdecal and stdcall mostly differ on this question: who cleans the stack? In the cdecal convention, the caller cleans the stack. However, in the stdcall convention, the callee cleans the stack. In both of those conventions, the return value is inside EAX, and also the last value pushed is the first argument. So basically they have the same order of arguments. Some exercises. You're going to fill in some code in some examples. It will help you understand the cdecal and the stdcall conventions. Then we will have some read code exercise where you will see some interesting examples. That's it for this lesson. See you next time.